Hello, and welcome to this lesson on polymers. In this lesson, we will introduce the concept that different polymers can be made from the same monomer by using different conditions. Next, we will compare and contrast low-density polyethylene and high-density polyethylene. First, let's briefly recap the monomer we are working with: ethene. Ethene is a simple hydrocarbon consisting of two carbon atoms double bonded to each other, with each carbon atom also bonded to two hydrogen atoms. When ethene molecules undergo polymerisation, they link together to form long chains, creating a polymer known as polyethylene or polyethylene. This polymerisation can be controlled by varying reaction conditions such as temperature, pressure, and catalysts, leading to different forms of polyethylene with distinct properties. Let's split the conditions and resulting products into two categories: LDPE and HDPE. To produce low-density polyethylene, the following conditions are required: high pressure at around 2,000 atmospheres, high temperature at approximately 200 degrees Celsius, and no catalyst. Under these conditions, the ethene molecules polymerize in a highly branched manner. The high pressure and temperature cause the polymer chains to form with many side branches, preventing the chains from packing closely together. This results in a material that is softer and more flexible. LDPE is commonly used in applications like plastic bags, cling film, and squeezable bottles because of its flexibility and toughness. Now, let's look at high-density polyethylene. To produce HDPE, different conditions are used. In this case, we need low pressure, at around 2 atmospheres, a moderate temperature of around 60 degrees Celsius, and a Ziegler-Natta catalyst. Under these conditions, the polymer chains form with little to no branching due to the lower pressure and temperature, as well as the presence of the Ziegler-Natta catalyst. The lack of branching allows the polymer chains to pack closely together, resulting in a material that is denser, harder, and more rigid. HDPE is used in products that require strength and rigidity, such as piping, strong containers, and plastic furniture. Let's now compare and contrast the properties of LDPE and HDPE. LDPE is soft, flexible, and has a lower melting point. It is suitable for products that need to be pliable and easy to mold. HDPE is hard, rigid, and has a higher melting point. It is suitable for products that require durability and structural strength. The differences in physical properties between LDPE and HDPE can be attributed to the structural differences in their polymer chains caused by the varying conditions under which they are produced. To help visualize this, imagine the structure of LDPE as entangled spaghetti with many side branches, making it difficult for the strands to stack neatly. Now, think of HDPE as straight strands of spaghetti packed tightly together, creating a stronger and more orderly structure. By controlling the polymerization process, chemists and engineers can produce materials like LDPE and HDPE that meet diverse needs in various industries. This ability to precisely tailor material properties greatly expands the versatility and utility of polymers in our modern world. In today's lesson, we delved into how different polymers can be made from the same monomer, ethene, by altering polymerization conditions. We compared low-density polyethylene, LDPE, and high-density polyethylene, HDPE, emphasizing the conditions required for their production. We also discussed their resultant structural differences and how these lead to varied material properties. Specifically, LDPE is suitable for flexible products like plastic bags, while HDPE is ideal for strong, durable items like piping. This lesson highlighted the importance of controlling polymerization conditions to tailor material properties for specific applications. Watch the rest of the GCSE chemistry course at Sophos Education.